Welcome to lecture number 27. So in today's session, we are studying about DTFT, the third Fourier representation of this chapter. To summarize the previous session, we could understand how to compute the Fs coefficient, that is Fourier series coefficient for the given time domain signal, and the inverse Fs for the Fs coefficients given, and you need to find out the time domain signal. So these two things we studied, and we also know that this Fourier series is applied for continuous time periodic signals. And in today's session, we are going to study about the representation in terms of Fourier for non-periodic signals. That is Fourier transforms and discrete time Fourier transforms. Let me share my screen. So topics to be covered in this session are non-periodic signals. For discrete time non-periodic signal, we apply discrete time Fourier transform. For continuous time non-periodic signal, we apply Fourier transform, right? So we are studying in detail in today's session about discrete time Fourier transforms, that is DTFT, and we will look into some examples as well. So here, the DTFT representation of the time domain signal is done by the equation that is in front of you. X of n is a discrete time signal, and it is represented by the Fourier transform coefficient, that is Ft coefficients, which is represented by capital X of e raised to j omega. In contrast with the previous series, Fourier series and discrete time Fourier series, we were using X of k, right? In both the case, here we are using X of e raised to j omega. So this is a difference between periodic and non-periodic signal. We use X of k in terms of periodic signal, time domain signal, and for non-periodic time domain signal, we use the denotation for representing the frequency coefficients as capital X of e raised to j omega in dt, and in ct e raised to j small omega. That's the difference. Okay, so e raised to j omega n d omega. So here it is integration, because here it is integration. I'm repeating, I'm stressing upon it. The meaning of this integration means this frequency component that we are extracting out of the non-periodic discrete time signal that we are providing will be of continuous form. So it's a continuous form ranging from minus pi to pi. So here you have a statement, you just have checked. X of e raised to j omega is the DTFT of the signal X of n. DTFT would involve a continuum. Continuum means series of frequency on interval minus pi till plus pi, where omega is measured in terms of radians. There is lot of meaning hidden in it. So the any discrete time non-periodic signal that is there will be having several frequency components, and when you try to extract such frequency components using DTFT, and if you just go on plotting a graph, so it will fall under minus pi to plus pi. And how many frequency component? There will be n number of frequency components. There will be infinite number of frequency component. Hence we call it as continuous series of frequency components. Continuum is nothing but continuous or series of frequency component. That is what you need to remember. Okay, so the inverse DTFT means the time domain signal you need to find out. So the frequency components are calculated using summation x of n e raised to minus j omega. You can see here x of n is a discrete time. For discrete time you cannot integrate. You are supposed to use summation. So that is what we have used here. So this is a DTFT pair. X of n is a time domain signal. X of e raised to j omega is a frequency domain signal. So by this you should try to identify which particular Fourier representation we are proceeding with. So if you represent it in this fashion, then it should be Ft, DTFT. Fs means there should be K. Remember that. Okay, I take the comparison of all the four Fourier representation by tomorrow or after completion of the four representations of the Fourier. So here we go on with the problems. So problems help us to understand the fundamentals in much better way. So the question goes like this: find the DTFT of x of n is equal to delta of n. So it's an impulse function. You need to find DTFT of it. So solution goes like this. The standard form or standard equation for finding out DTFT coefficients are x of e raised to j omega is equal to summation minus infinity to plus infinity x of n e raised to minus j omega n. This equation I have taken from this particular ticked one. Same equation I have taken here. Now the solution proceeds in this manner. So this is equal to summation n is equal to minus infinity till plus infinity. In place of x of n, I am having delta of n. And remember one thing, here we are writing only omega. In previous cases, in series, we were normally writing omega naught, w naught or small omega naught. So omega naught or small omega naught, these things we were using for periodic. Remember this. These are very important. So if you don't use omega naught or just a small omega naught, if you use just omega, then it is for non-periodic. This is how the author have represented. Okay, you need to follow the same thing. So you know that impulse functions properties you are already aware of. This delta of n will be 1 only for n equal to 0, and it's a multiplication. For n is equal to 0, if you substitute, it will result in a finite value, non-zero value. So I substitute n is equal to 0. We know that delta of n is equal to 1 for n is equal to 0. So hence we get it as I substitute 1 dot e raised to 0. So it will result in 1. So therefore the frequency component for the given signal is 1. So in terms of DTFT pair, if I want to write, so I write it like this. This is 1. So in terms of diagram, if I want to write, so if x of n is given by delta of n, this is delta of n, we represent as 1 at 0, then x of e raised to j omega is a DC signal. It's 1 always. That's the meaning. So it varies with respect to capital omega. So this is 1 throughout. Okay, but you know that we have studied in the previous slide that DTFT would involve a continuum of frequency on the interval minus pi to plus pi. So if you just write minus pi to plus pi, that's sufficient, because thereafter it goes on continuing, same thing. Okay, it's because after minus pi to plus pi, it will be periodic in nature. You just remember. Find the DTFT of an exponential sequence x of n is equal to alpha raised to n u of n. Solution goes like this. Standard form I have written as in the case of previous problem, and here I have written some standard formula which we have come across many times in previous sessions. Summation n is equal to 0 to n minus 1 alpha raised to n. The formula is for alpha not equal to 1, the formula goes like this: 1 minus alpha raised to 1 plus than the upper limit. N minus 1 plus 1 means n divided by 1 minus alpha. This will be very useful here. That's why I have written here. So I substitute x of e raised to j omega is equal to summation n is equal to 0. Why 0? Because it is given as u of n. So u of n exists only for n equal to 0 till infinity. So in that range, u of n will be 1. So I just write alpha raised to n e raised to minus j omega n. So this is equal to summation n is equal to 0 till infinity alpha e raised to minus j omega whole raised to n. That is how I write it, and whole raised to n. So here what alpha's value has been not given. So what if alpha's value is greater than 1? If mod of alpha's value is greater than 1, what happens? If alpha is greater than 1, for example, here alpha is there, think that I am taking number called 2 raised to n. If I use a summation, so what number it will generate? So if n goes on varying from 0 to infinity, it goes on increasing. 2 raised to 2 4, 2 raised to 3 8, 2 raised to 4 16. It goes on increasing, right? So when it goes on increasing, we call it as the signal diverges. That's what I wanted you to answer. The sum diverges for alpha greater than as well as equal to, because even summation of 1, if you add 1 for a number of times, it will also lead infinity. So that's why. So hence it is not stable, so I don't go for it. And you know that Fourier representation is applied only for stable system. That is what the Dirichlet condition said, right? So if alpha is less than 1, if it is in the range 0 to 1 or -1 to 0, then I can apply that standard form. This standard form I'll apply. So 1 minus, in place of alpha, what I'm having? I'm having alpha e raised to minus j omega I'm having. So here the upper limit is infinity, right? So if it is infinity, so here it goes to infinity. So one second. So this one I'll extend here. There is one more standard form I'm supposed to write. I'll just write that. If it is 0 to infinity, 1 divided by 1 minus alpha. That's what. So that's it. Okay. So I'll just edit this equation because the upper limit is infinity. So my work is very simple now. That's why. So 1 divided by 1 minus alpha e raised to minus j omega. So that's it. So this is applied only for alpha less than 1. That is what you are supposed to remember. So therefore, summation e raised to j omega is equal to 1 divided by 1 minus alpha. E raised to minus j omega can also be written as cos omega minus j sin omega by Euler's theorem, right? So by Euler's theorem, you can also write it in this fashion. Fine. So next, I'm taking the same equation here. Why? Because so in your question, if it is asked to find out the magnitude and phase equation also, then this is very important. So I find magnitude first, magnitude x of e raised to j omega mod. This is given by 1 divided by, so I 1 is a real quantity, alpha cos omega is a real quantity. After j, whatever you have, that is imaginary quantity, right? So 1 minus alpha cos omega is one the real quantity, minus j sin omega is your I can say imaginary quantity. Still I have not taken the magnitude, so let me take the magnitude here, e raised to j omega. So the magnitude is computed as square root and square of 1 will result in 1 itself. So squaring of the real separately and the imaginary separately. So square, okay, then plus, because this also I need to square. So minus goes, so you get it as, I think alpha is, it is bracket, in bracket it is multiplied with cos as well as sine. That's why I have introduced alpha here. So alpha square sine square omega square root. So this is how the magnitude is computed. Okay, so if you compute this, you will get it as 1 plus alpha square cos omega square plus minus 2 alpha omega plus alpha square sine omega is there, sine square omega is there, sine square omega and cos square omega will become 1, so only alpha square will be left out. So you get the answer as alpha square plus 1 minus 2 alpha cos omega, its square root. So this is your magnitude. Now similarly, if I ask you to find the phase, phase is computed as angle. This is computed as tan inverse of imaginary part divided by real part. What is imaginary part? So this is a main quantity. If I want to rationalize it, how do I do it? So this is a real quantity, right? 1 minus alpha cos omega. So here it is minus. I have to take it as plus j alpha sine omega. Same thing in the denominator. We write it as alpha sine omega divided by 1 minus alpha cos omega. So this is your phase response. So we will proceed with the next part or next problem, that is find DTFT of x of n is equal to 2 into 3 raised to n u of minus n. So concentrate here. So first you need to write the standard form. The standard form is x of e raised to j omega is equal to summation n is equal to minus infinity to plus infinity x of n e raised to minus j omega n. So for this, if I supply u of minus n means what? N ranging from minus infinity till 0. That's the meaning, right? So this 2, I take it outside. So what is that? 3 raised to n e raised to minus j omega n. X of n is 2 into 3 raised to n. So 2 I took it outside and this is what I get. So let n is, or I consider p is equal to minus n. So because minus infinity to 0 is a bit difficult to solve, that's why I'm taking like this. 2 summation, I'll put p here because minus n. So if n is minus infinity, p should be infinity. So it gets reversed. If I just inverse the signs, it gets reversed. Wherever n is there, you have to write it as minus p. Minus p. That's it. So you get it as 2 summation p is equal to 0 till infinity. So p, I'll take it outside. What is left out? 3 inverse. 3 inverse is nothing but 1 by 3. And this minus and this minus gets cancels. So p is taken out. So what is left? E raised to j omega. So for whole, I'm writing raised to p. So this is equal to 2. Apply the standard form. There is an infinity. So hence it is 1 divided by 1 minus alpha. In place of alpha, I'm having 1 by 3 e raised to j omega. So that's your answer. So you can further simplify it as 2 divided by 1 minus 1 by 3 e raised to j omega is the answer for the frequency component x of e raised to j omega. Very simple. So like this, small deviation again with a problem. So variety of problems we will solve. So here we have been asked to find out the DTFT again. Time domain signal is given. DTFT has to be found out. So again, I'm writing the standard form. So repeatedly, I'm writing the standard form because you should remember this is very important step in your answer. Okay. So I substitute n is equal to, I substitute the same thing. Delta of 6 minus 3n plus delta of 6 plus 3n. Whenever impulse functions appear, you should be very careful. Okay. And it is such questions you can expect in your GATE exam also. So here, what you have to analyze is, separately you take summation n is equal to minus infinity to plus infinity delta of 6 minus 3n e raised to minus j omega n plus again summation n is equal to minus infinity till infinity delta of 6 plus 3n e raised to minus j omega n. So I consider these two things separately, and you know the property of the impulse function that this quantity, I change the ink for your explanation, this quantity should go to 0 in order to have a finite number, have a non-zero value, because delta of n will be 1 only when n is equal to 0. Similarly, delta of 6 minus 3n will be 1 only when this quantity goes to 0. So when this quantity goes to 0, that we need to decide. So substitute n value such that this quantity has to go to 0. So what value of n have to put it here in order to make this quantity 0? So if this quantity goes to 0, delta of 0 will result me 1. The same quantity of n I'll be putting here. That gives me the answer, final answer. So what is the value of the n I have to put it here? You need to put n equal to 2 here. So here n is equal to same thing is there, only sign is reversed. So I change the reverse sign. So I will put that in the next step. So we will see what happens. So this will give me 1. This becomes 1 e raised to minus j omega. In place of n, I have to put 2. Plus this becomes 1 minus j omega minus 2. So you get it as e raised to minus j, or 2j omega, plus e raised to minus minus cancels j 2 omega. So I write it in the normal, this one first, e raised to j 2 omega plus e raised to minus j 2 omega. So how we can write this? So if you imagine 2 omega as theta, e raised to j theta plus e raised to minus j theta, I can write it as 2 cos of 2 omega. That's it. That is your answer. So in your examination, if we want to twist, we will twist it like this. In place of 3, we will give it as 2. So in place of 3, what we are doing? I'm giving it as 2. So what happens? So if I give this as 2, this as 2, so what happens? N value becomes, here it should be 3, right? It should be minus 3 because 2 into 3 will give me 6. 6 minus 6 is 0. 2 into minus 3 will give me minus 6. Minus 6 and 6 goes cancels. So wherever you have 2, I have to replace it with 3. So you get the answer as this way. So this is a change. Okay. The next problem is the DTFT of rectangular pulse. The DTFT of the rectangular pulse is also given and the mathematical model is also given. So this is a discrete time signal. Hence, the triangular waveform is looking. This is dotted. Dotted means you have like this everywhere, ranging from minus m to plus m, minus m to plus m, or else we can write it as n mod less than or equal to m. So it is 1. Within this range, it is 1. Out of that range, it is 0. That's meaning. So if I want to produce the answer for it, then this will give me, this is equal to summation n ranging from minus m till plus n. X of n value is 1 here. It is given 1 dot e raised to minus j omega n. Okay, so what we do is we perform some change of variable now. So what I do is this, rather than minus m to m, because I don't have a straight formula for this. So what I do is I shift this n to 0. So if I shift this n to 0, so this will become, this will again shift by m. So what you get? You get it as summation n is equal to 0 till 2m. Till 2m, you get it as, so or else I can make it much more easy. So what I do is, so here n, this minus m taken onto the left hand side, what do you get? N plus m. This one n minus m, I took it on the other side. So I name it as small m. Let me name it as p. Let us not confuse it, small m, p. So if this is the case, then when n is equal to plus m, when n is equal to plus m, so it is m plus m, it is p, 2m. Okay, so but what is the value of p? P is equal to n plus m. That is what you should remember. Okay, so wherever n you have, this one, wherever n you have, n is equal to p minus m. That is what you need to substitute. So here n is equal to 0. I can say p now. So it is p. P is equal to 0 till 2m e raised to minus j omega. So n can be written as p minus capital M. Then we get it as, I take this term separately. You can see here. I write it here itself. 2m e raised to 1 second. E raised to minus j omega p, this minus and this minus, j minus minus plus j m, right? J omega is also there, omega m. So for that, this is independent of, I can write it omega here. Okay, this is independent of p, hence I take it outside. It's a constant. This is a constant. I took it outside. So what is left inside? P is equal to 0, 2m e raised to minus j omega p. Okay, so I can write it as like this, raised to p. So I can apply the formula. Okay, the formula in the previous slides I had shown right? So that formula I apply e raised to j omega m. For this I apply formula now 1 minus alpha raised to upper limit plus 1. Alpha is e raised to minus j omega. Upper limit plus 1 means 2m plus 1, right? So this is like summation alpha raised to n, and there is a standard formula 1 minus e raised to or alpha raised to n plus this maximum upper limit plus 1, that is what I'm doing, divided by 1 minus e raised to minus j omega. That's it. Okay, so this is the one intermediate form. So then we will proceed in this manner. So the same equation I have written here, same equation. Okay, so now from now on we will proceed with the further things. Why? Because if I substitute omega is equal to 0, so this is for omega not equal to 0. Why? Because if you substitute omega is equal to 0, then what happens? E raised to 0 is 1, 1 minus 1 is 0. So denominator should never be 0. If at all you get a denominator as 0, then it is not a number. N we call it as, not a number. Okay, so if you get a not a number, then what you have to do is such value of constant, that quantity should not be put. Here omega is not equal to 0. That is what you need to write. Now what if I put 2 pi here? E raised to minus j 2 pi. That is nothing but cos 2 pi minus j sine 2 pi. Sine 2 pi is 0. Leave it. Cos 2 pi is 1. 1 minus 1 is again 0. So even 2 pi is not possible. It should not be equal to 2 pi. If I put minus 2 pi, minus minus cancels, j 2 pi, cos 2 pi plus j sine 2 pi. Again it will result in 1. So plus or minus is not okay. And even plus or minus 4 pi is not okay. And it goes on. Then what we are supposed to do? You have to apply the L'Hospital's rule. Apply L'Hospital's rule. That is what we are doing now. So I have here. So L'Hospital's rule. Okay. So when omega is equal to 0 plus or minus 2 pi and so on, it's a 0 by 0 condition. So apply L'Hospital's rule. If you apply L'Hospital's rule, limit tending from omega tends to 0 or plus or minus 2 pi, multiples of 2 pi, I write this equation as it is, and this numerator and denominator I differentiate. If I differentiate, after differentiating constant, it will go to 0. So leave it. So what you get it as, after differentiation, you get a minus sign, and this minus sign cancels. Here also this minus sign cancels. What is left here is, other than omega, you have 2m plus 1. That is what I'm writing. E raised to minus j omega. So here also you get e raised to minus j omega as it is. So this is a quantity when I differentiate on numerator and denominator. So after supplying 0, for easiness, we will supply omega equal to 0. If I supply omega equal to 0, e raised to 0 is 1, e raised to 0 is 1, e raised to 0 is 1. So here 2m plus 1 was missing. So that's why I took it here. You can see here e raised to 0 is 1. This is also 1. This is also 1. Only this is left. So hence x of e raised to j omega is equal to 2m plus 1 when omega is not equal, when omega is equal to 0 plus or minus 2 pi plus or minus 4 pi 6 pi 8 pi so and so. In simple words, we call it as plus or minus 2 pi m or n, or we will write some other quantity small m. Okay, so next I bundle it like this. X this quantity, this answer is for omega not equal to, so this answer is for omega is equal to 0 and so. So it may be further simplified by symmetrizing the powers of the exponential in the numerator and denominator. I take the same quantity, and you just see how I simplify it. I'm taking the same quantity, okay, and this is optional, and it is always good to come out with a very much simplified version. If the problem is asked for more marks, and if you don't simplify it to the dead end or the ultimate answer, you will lose 1 or 2 marks, but we cannot say the answer is right, but you will not get full marks. That's the only thing. Okay, so here what I'm doing is, the equation looks big, but I'll tell you what I have done here. See here, this e raised to j omega m I'm retaining as it is. Here what I'm doing is, I am taking a common, the term called e raised to whatever I'm having here, this divide by 2, that is what I'm taking common. So if this divide by 2, if I take common from it, so another half will be retained, so that is written here. And from 1, if you take it, so I should retain 1, right? So if you multiply these two things, minus and plus, it get cancels and you will get e raised to 0. E raised to 0 is 1. That is what I'm getting. This one you can easily understand. You just here. E raised to minus j 1 by 2 or omega by 2 is taken common. So what is left? Another half is left. E raised to minus j omega half is left. So for retaining 1 here, so minus j omega by 2 plus j omega by 2 cancels, e raised to 0 is 1. So that is what I'm getting. What is the intention of doing this one? The intention is quite simple. I need to simplify it to the maximum extent. That is what I'm doing. So e raised to j omega m as it is written here, right? And here what I'm doing is e raised to minus j omega 2m plus 1 2. That is also written. This part is written as it is. Here you just here e raised to j theta minus e raised to minus j theta means just you according to Euler's formula I can replace with the sign. So I should have the 2j sine theta. Rather than writing here, I have written here 2j sine theta. In place of theta, I have omega 2m plus 1 by 2 that I have written 2j is here. Similarly here, e raised to j theta minus e raised to minus j theta. Again 2j sine omega by 2. So 2j is here, 2j cancels. I'll be left with this. Now what I'm doing is, here you just check. 2m by 2 is m plus 1 by 2. I'm writing here. You just here. This and this I am adding. J omega is taken common. M if it is added, what do you get? M, this m, and minus 2m by 2 is just m, 1 by 2. So this m and this m cancels. So you will get as e raised to j omega by 2. This is also e raised to j omega by 2. This and this cancels. These two get cancels. Okay. So you are left with sine omega by sine omega 2m plus 1 by 2 divided by sine omega by 2. So this is the answer for omega not equal to 0 and multiples of 2 pi, and 2m plus 1 for omega equal to 0 and multiples of 2 pi. So it looks big, but simplification is must. So we'll proceed with the next example, that is DTFT of the given signal x of n is equal to omega n minus n naught. The standard form is the frequency component x of e raised to j omega is equal to summation so and so. The standard form is taken as it is. So now what you're supposed to do is you need to substitute delta of n minus n naught here and just show it. Delta of n minus n naught in place of x of n. Then you know that this quantity has to go to 0 in order to have a finite number, non-zero value. So when can this quantity goes to 0? What value of n I have to substitute here in order to make it 0? So I have to substitute n equal to n naught. So when I substitute n equal to n naught, put n is equal to n naught. So you get 1 here dot in place of n you write it as n naught. Then you get it as x of e raised to j omega is equal to e raised to j omega n naught. That's your answer. We shall go to the next one, seventh problem. The standard form is like this. So x of n, I substitute u of n minus u of n minus 6. These two things, if I draw the diagram, u of n means, so at 0 I'm having 1. So everywhere I'm having 1. U of n minus 6 shifted, same signal shifted by 6 times. So from here it starts having 1 thereafter. If you subtract these two things, you get it as here 1, here 1, here 1 till 5 you'll be having 1. This is a given x of n. So it ranges from 0 to 5. 0 to 5, the value of u of n minus n to minus u of n minus 6 is 1. So e raised to minus j omega n. So if I apply the formula of summation alpha raised to n, so I get it as 1 minus alpha raised to the upper limit plus 1, 5 plus 1, 1 minus alpha. In place of alpha, I'm having e raised to minus j omega. So that is what I got it here. So this is your answer. 5 plus 1 is 6. Very simple. Okay. So such problem can be asked for 5 marks or 8 marks or 6 marks and all. The next question, you can take it as an assignment. So take it as an assignment. because it goes in the similar ground. So the answer for this is you have to apply the summation alpha raised to n formula. So 1 minus alpha raised to n plus 1 divided by 1 minus alpha. That same formula I have to apply. The limit is also given 0 to 9. So hence 9 plus 1 is 10. So you'll get the answer. Please try it at your end. Okay. So take it as an homework. So now we will come to the next part, that is inverse DTFT. So inverse DTFT, we have to use the other equation. The other equation is time domain equation representation. X of n is equal to 1 by 2 pi minus pi to pi integration x of e raised to j omega n d omega. Okay, you know that we had given a statement that it is found, or it is restricted to minus pi to pi, right? So you know that delta omega is equal to 1 for omega is equal to 0. Hence x of n is equal to 1 by 2 pi integration of delta omega e raised to j omega n d omega. So what you get is omega will result in finite number non-zero one only when omega is 0. So I substitute omega as 0. So what I get? So this I'll get as 1. This I'll get it as, so delta of 0. This I'll get it as e raised to 0 d omega. So what happens here is integration of impulse function is itself is 1. Remember. So people commit mistake by writing 1 and after taking integration it goes the other way. Don't do like that. Integration of impulse function is itself 1 because it is area under the curve. That is what we are writing in the impulse. So that's why this is also 1, this is also 1. Your answer is 1 by 2 pi. So remember, so if your 1 by 2 pi is a time domain signal, then if you take the DTFT in the forward way, you'll get as delta of omega. If you take inverse DTFT, you'll get the other way. So this way. Okay. So remember this. So if I want to plot the graph, so it would look like x of e raised to j omega, if it is delta of omega, so you get it as 1 by 2 pi. 1 by 2 pi as the answer. 1 by 2 pi as the answer. So this is how you get it. So next, the inverse DTFT of square wave. So I be quick in explaining these things. So there is a square wave given. So I apply the standard formula. The standard form is x of n is equal to 1 by 2 pi integration from minus w to plus w. I don't write minus pi to plus pi because minus pi to plus pi there is some value 0. So I consider it only for finite values. I have 1 here, e raised to j omega n d omega. This will result in 1 by 2 pi. So integration of e raised to j omega will result in e raised to j omega n divided by, so other than omega, so whatever is there that I write j n. So limits w and minus w. So you get it as 1 by 2 pi e raised to j w n minus e raised to minus j w n. Okay, so in place of this jn, I do one thing. So here jn should be taken outside. I write it here jn. Okay, I write it here. So you know that this is like e raised to j theta minus e raised to minus j theta. So I can write it as 1 by 2 pi jn. This is by Euler's formula. I can write it as 2j sine, in place of theta I'm having wn, right? So this j and this j cancels, this 2 and this 2 cancels. So what is left is 1 by pi n sine wn. So this is your x of n. And before you conclude this as an answer, check by substituting n equal to 0. N equal to 0 in the denominator, n equal to 0, 0 by 0 form again. So hence it will result in not a number. Hence you should write it as for n not equal to 0. So if n is equal to 0, what I'm supposed to do? So apply L'Hospital's rule. This is very important, okay? L'Hospital's rule. If I apply L'Hospital's rule, then x of n is equal to limit n tends to 0. Differentiate numerator and denominator. If I differentiate numerator, I get it as cos wn. So w is a constant. So that also I write here. I differentiate with respect to n. So what do you get? You get only pi. So now you substitute n equal to 0. What do you get? X of n is equal to. So if I substitute n equal to 0, cos 0 is 1. So what is left out? W by pi into 1. This is equal to W by pi. For n is equal to 0 it is. So this is the answer. So x of n is equal to, I can write it as sine Wn divided by pi n for n not equal to 0 and W by pi for n equal to 0. That's it. Okay, simple, very simple. Now the same equation I have taken here and I want to bring it in the form of sinc function. Okay, sinc form and sinc function. So in terms of sinc function, how do I write it? Just to see here, I take this quantity for n not equal to 0 and same thing, Wn pi n is there. Now here I introduce the quantities like W by pi, both cancels, pi and pi both cancels, original signal is written as it is. Now you just see what arrangements I make here. W by pi as it is I have written here. Now this pi I write it and this is u, like sinc is nothing but sine pi u divided by pi u. So I write pi and rest everything separately. So hence I get x of n is equal to w by pi sinc of wn by pi. So now if I plot this graph, so if I substitute n equal to 0, I get it as w by pi. That is what I write it here. And if I substitute n is equal to minus pi by w means w cancels, sine of minus pi or sine of pi will result in 0. So that's why this quantity, these two quantities. So if you mark these two things, your equation or your diagram for sinc function is done. Sinc function for discrete time will look like this. Fine. Next one. Find the inverse DTFT of the given signal 2 cos 2 omega. The standard form is given in front of you. So now hardly two more problems are there. So we will wind it up in another 5 minutes. Okay. So x of e raised to j omega is equal to, so I can write this 2 cos 2 omega as 2 into the bracket Euler's formula, e raised to j 2 omega plus e raised to minus j 2 omega divided by 2. So this is Euler's formula. This 2 and this 2 cancels. So I get this one. Okay. So now what I do is I take the equation number 1. This I call it as equation number 1. This I call it as equation 2 because this is nothing but question itself, equation 2. Now what I do is I elaborate equation 1. So what if I elaborate equation 1, the standard form, this would look like this. This is equal to, I take few quantities like x till minus 2 to plus 2 I'll take. So I get it as x of, in place of n I put it as minus 2, e raised to minus j omega, in place of n I put it as minus 2. So whenever you have trigonometric function, use this inspection method. Okay, plus I quickly write, okay, so plus x of 0, if you substitute e raised to 0 it will result in 1, plus if you substitute 1, x of 1, e raised to minus j omega 1 plus x of 2, e raised to minus j omega 2, right? So now yeah, I'll change the ink for better understanding. You compare here. So where I can get this, these two, this and this, e raised to j2 omega, e raised to j2 omega is here. See here, minus j, minus and minus goes to plus j2 omega. So this quantity, and for minus you have this quantity. Rest everywhere is not present, so I can omit it. So this I can do by inspection method. So hence by comparing or inspecting by inspection, we get x of minus or x of minus 2 is what? Because here you have e raised to j to 2 omega. It is e raised to j 2 omega. Okay, I have 1 here. Okay, these all are 0. So x of 2 is, that is also 1. So hence I get it as, so for your simplicity I write it once again. This is x of minus 2 e raised to j 2 omega, plus this is x of 2 e raised to minus j 2 omega. So if I compare these two things, I would have got these values. So therefore x of um, n is so x of n is, I get 1 for, these two are 1 for n is equal to plus or minus 2, 0 otherwise. That's your answer. Okay, next one. Find inverse DTFT of delta of n minus n naught. Very simple one. 1 by 2 pi minus pi 2 pi delta of omega minus omega naught e raised to j omega n. Very simple. So this quantity has to goes to 0 to have a non-zero number. So when it will go to 0? When omega is substituted with omega naught. So when I substitute it with omega naught, I get it as, you know that this quantity, whole quantity goes to 1. 1 by 2 pi into e raised to j omega naught n. Okay, so omega naught I have substituted, omega naught n. So this is your answer. This is your answer. Okay, so I have solved around 12 problems for the DTFT, discrete time Fourier transforms. I repeat once again, it is applied for discrete time non-periodic signals. Non-periodic signals. So this completes your DTFT and inverse DTFT. So we shall conclude today's session. Thank you.